just assume this highlighted section is one data frame and this highlighted section is another data frame. So this is data frame A, this is data frame B. So join or concatenation is about, on a certain condition, we are adding these two and making one master data frame out of it. Let's say this one. So this plus this, sorry, this plus this is equal to this, something like that. So that is what join or concatenation is all about. Now, if we go specifically into join, then it's better if I can take you through this thing, some images with some examples. So it will be easier to relate and understand. Let me this one, gigs for gigs. So basically joins are of these many types. So basically there are two types, inner join and outer join. Inner join means whenever, let's say, let's create this one. This is ID and this is name. This is ID, this is location. Right. So 1, 2, 4, 6, 7, and 8. And let's have this one as 1, 3, 4, 5, then 7, 9, like that. Okay, and just putting some names here, random names. Okay, this is done, and location, or let's make it age. By 2. Okay. Let's say these are two different data sets, right? Data frames. So this is one and this is another one. So we have been asked to add them together, but how to do that? So that is the first thing. How do we add them up? Just making a little bit more presentable. Now it looks better. So there are two types of joins here. One is inner join, one is outer join. So what are they? So inner join means only the common elements between these two will come on the final data frame. That is inner join. And outer joins are what? Outer joins are something where everything will come together. It's not only the common ones, but things which are not common. Right? Things which are not common, that will also come. Now, why I'm talking about this common or not? So based on what? Based on a column. For our case, it will be based on column ID. So if we consider this particular column, because that is the common element between these two tables. So ID here and ID here, that is the common one. Now, what we will say, we will see if, the common elements of these tables and the common elements of this table. So how many of them are common? Number 1 is common, ID 1 is common, 2 is not there, 3 is not there, 4 is common between both, then 7 is common. So these are the three. So the final data set that I will be having will have these three, and it will look like, let's say, name and age. Now, for one, the name is this, and for one, the age is this. So I have these informations, right? So whenever it's 4, I have the name. Whenever it's 4, I have the age. Whenever it's 7, I have the name. Whenever it's 7, I have the age. So if I do an inner join, this is what I'm going to get. So this is the result of an inner join. Right, Sian, you following?
Yes.
Ranjit?
Yes.
Yesterday,
We saw, no?
yeah, yesterday we talked about, but just, to get Sian up to speed. So we are kind of repeating.
Okay, no problem.
So yeah, so this is the thing. Now, this is inner join because we are taking only the common elements. We call it inner. That means only the common elements. There is something else which is outer join. Outer join will take everything together. So all the rows, all the numbers, all the things, everything will come here. But before going into outer join, let's do the inner join once more because inner has two things. One is a left inner, and one is a right inner. These are two more subcategories of inner join. So first is inner, then within inner we have two, left inner, right inner. What is left inner? So if this is a join based on the common element ID, then this will be my left table, which will be before the join condition, and the join statement, and the table after the join will be my right table. So this is left, this is right. Now left inner join, what this will do, inner join are the common ones, we have seen that, right? But what left inner will do, left inner will keep all these IDs from the left table and only the common IDs from the right table. That means, so if I have to create a left inner, so all the IDs will come from the left table. All the IDs will come from the left table. But from right table, I will only see the common ones, not all. That will be my left inner. So if I have to create like this, what will be the condition? So uh, all the names will come here, right? And now let's see for age. For one, we have an age, yes. For two, do we have an age? No. For two, we don't have because two ID is not even there in the right table. So what will happen? This will be missing. This will be missing value. Right. For four, do we have age? Yes, 21. For six, do we have age? No. Then
No.
again, this will be missing. For seven, we have 39. And for eight, we don't have. So again, this will be missing. So this will be the output of my left inner join. If I do a left inner join. So left inner join will keep the left hand side table and the common elements from the right table. So that is a left inner join. Similarly, just replace the left with right. What will happen? It will keep all the right IDs and the right age and the common names which will fall for these IDs. So that will be my right inner join. Okay, so that's all about inner join. Now that is okay, that is fine. That is on the inner join. Now what about outer join? Outer join. What is outer join? Outer, as the name suggests, it's taking everything together. So outer will have all the records, all the common IDs and the IDs which are not common. Everything. So if I have to create ID, so 1, 3, 4, 5, 6, 7, 8, 9. So all the elements will come. Now, I have to see if the relevant information is there or not. So let me do like this. So 1, 2, this is not 3, this is 4. So 3 we don't have. So 3 will be missing because we don't have a name for ID 3. Similarly, or let's keep it blank. Missing. 4 we have, 5 we don't have. So 5 we don't have. 5 will be missing. 6 we have, 7 we have, and 8 we have. 9 we don't have, so 9 will be missing. So this is on the name, and what is on the age? For 1 we have age, yes. For 2 we don't have. This just copied. 3 we have. 4, 5, 6 we don't have. Put it here, 6. 8. Yeah. 9 we have, for 7 we have 39. For 5 we have 38. For 4 we have 21. For 3 we have 42. So this will be the outcome of the final outer join. Right. So whenever there is a mass, so the point is every join will happen based on a condition, based on a common key, based on a common element or a common column. For our case, the common column is ID. That has to be there. The common column has to be there. So this, based on this common column, the joins will happen. Now, whenever there is a match, you will have that result. Whenever the match is not there, you will get a missing value. As simple as that. As simple as that. So that is on the joins. Now here, it has done the same thing. Yeah. So this is the picture I wanted to show you. So imagine if these circles are tables or data frames. So there are two circles. So this is circle 1, this is circle 2. So the common element, the common area, the shaded area. So this is basically your common elements where the IDs are common. So we have seen here, right? Like 1 is common, then 4 is common, then 7 is common. So these 1, 4, 7 is this area where the same ID is present in both the tables. So this is your inner join. Similarly, now this is left. Yeah, this is left inner join, the one that we have just seen. So the left inner join, what this will do, or usually we call it left join. I mean, both are same, left inner or left. You can write it like that. So what this will do, it will take everything from the left table and the common elements, like we have seen, right? So left inner join or left join will take everything from this and the common ones which are present. For those edges, we will have a valid one. For whenever it's not there, we will have a missing populated. That is left inner. Similarly, there is a right inner. This is a right join where right tables, everything will come, and left tables, only the common things will come. And there is a full outer join where everything will be there. Now, whenever I'm having everything like this one, I don't have data for all, so I'm getting a missing here. That's it. So this is all about join. So we understood, right? This is all about joins. Now let's see here what we are trying to do. So what we are trying to do is to create two data frames in Python. So we have used two dictionaries to create for quickly. So one is EMP, one is LOC. So EMP has name and ID, and LOC has, let's say, location and ID. So ID is the common bit. So ID is the common between employee and location. So how do we do it? So in Python, we have to use dot merge. Dot merge. So this function will do the join on your behalf, right? So if you open notebook and press Shift tab, okay, it's not running. So I have to execute these lines again. In that case, let me quickly. Yeah. So if I do a Shift tab, this will show you what are the things you can do. So merge data frames. Basically, it's used to join, right? Based on a common element, or if there is a common element or not. So how it's happening? So employee one, this is a new one, is equal to employee. So this is a data frame dot merge. So employee, I'm merging employee with LOC. LOC is there, and on ID. On ID, right? On what is the common element? ID. So whenever there is a match, just do the join. So this is a type of inner join. So if I don't specify anything, it will by default do the inner join, means the common elements. So what are the common elements? So 34 is the only common element between both, right? So that is what the outcome I'm getting. Only one element 34. One table is giving the name, another table is giving the location. Hence, I'm getting this row. If I do a merge, an inner join. Similarly, there is an option to do left join. So just the additional thing is you have to specify this. How is equal to join. So how means what type of join you want. That is what you have to tell Python. So how is equal to will tell you if you say left, then it will do a left join. Left join means whatever is on the left hand side, that is employee. So employee 12, 14 and 34. So your table will have these many IDs because that is on the left hand side and this is on the right hand side, right? So employees, all IDs will come. So which is 12, 34, 14. 12, 34, 14, John, Sam, Martin, that is fine. From the right table, it will, based on the common IDs, it will fetch the results. Now, from the right table, only 34 is matching. So it will get only this location. And for the other, I'm getting this. Now, what is this? This is Python's way of telling there is a missing value. This NaN, is a Python's way of telling this is a missing value. In other programming language, we might see a blank or something else. But in Python, whenever there is a missing value, it will, if it is a categorical, like characteristic in nature, it will tell that this is NaN. If it is numerical, it will be a dot or something. So yeah, so that is left join. Then we have seen the same thing for right join. And so this is a full outer join. This is outer join. This was not written properly. All from both the tables. Right. So that is how it will be. So outer join. So this is the example I just showed here. That's exactly this example. So things which are common in one table will come. Things which are present in another table will come. Otherwise, it will just put a missing. It will just put a missing value. That's it. So that is all about joins. Now, there is one more thing that we explored yesterday. What if the common elements column name is different? So we want to do a join, but let's say these two are coming from two different data sources. That is why their column name is different. One has ID1, one has ID2. Now to solve those kind of situations, Python has given an option which is left on and right on. So until now we were just using on. Until now we were just using this on statement, where on is a function argument where we have to tell is it on what column. But here, as the ID names are different, I have to tell the left on this and the right on will be this. That means on the left hand side, the common column ID's name is ID1, and on the right hand side, the common ID's column name is ID2. And that is how you can do a join. So that is one more thing. Now, if there are multiple elements, then we can use a list. That is also we have seen here. We can use a list and put all the elements, all the column names. So that is on the joins. And then, so that part is fine. Now, an important thing is, which is concatenation. So concatenation, so join we have seen, join happens based on a certain common element. It's not repeating rows. It's not repeating columns. If the column is there, it's having, if the column is not there, it's just ignoring that. That is what is happening for joins. But for concatenation, let me just take this example because this is a really good example. So what is concatenation? So what concatenation is basically, as the name says, and this name is used, you would be able to understand it clearly. Concatenation meaning. Let's see the meaning of it. A series of interconnected things. That is what concatenation means. Things which are connected together. That means things where this plus this will happen without using any condition. In joins, we had a condition, there has to be a common element, there has to be a common key. That is not the condition for concatenation. So blindly, it will just add two data frames and create one. Now, the only difference here will be your axis. So how this happens? So here it concatenation happens as part of the pandas module. So pd.concat, pd.concat, and within pd.concat, within a list, you have to specify the data frame names. So this is data frame 1, this is data frame 2. So within a list, if you specify this, that's how the concatenation will work. Right? So if I had to do the concatenation here, or let's see it here itself. So there are two data frames, employee and location. If I use pd.concatenation and use axis equal to 1. Now just remember this line, axis is equal to 1 is for columns. So concatenation is something which can happen both ways. Concatenation is something which can happen both ways. What do you mean by both ways? Horizontally or vertically. It can go in this direction, it can go in this direction. Now what they are, if I'm talking about horizontal, that means I am just adding tables one after another. I am not increasing number of rows, but I am increasing number of columns. So this is horizontal addition. This is axis is equal to 0. But so this is something which goes in this direction. So if there is one more table and then it will come here and so on and so forth. So this is something which is expanding horizontally. But what is axis is equal to 1? Something which will happen vertically. So how that will happen? Now this, let me just remove this. So how that will happen? Now this will come here. I've used axis equal to 1. So all this will be copied and they will be appended here at the bottom of it. Now here comes the interesting part. It will see whether the column names are matching or not. Now the first column name is matching. The first column name is matching. So it will take these values and it will basically append them here. It will append all the elements here. But next, it will encounter that age is not there. This column is rather name. So what it will do, it will create a new column age, and then it will bring these values here. Right? Then it will bring these values here. But then what about the others? Simply missing. Simply, they will be missing values like nans or whatever. These will be missing. These will be your missing values. So this is all about concatenation. Now see here what is happening. So here, if you don't specify what type of concatenation you want to do, by default, it will happen on axis equal to 1. Vertically, if you don't specify anything. But if you have to specify, it will work accordingly. So 1 is basically for columns. Whenever you want more number of columns to be added, like in joins, we will use axis equal to 1, else we will use axis equal to 0. So here what is happening, that exactly same thing. So name and ID, these are common in one table. So we had these informations. This is one table, hence it has added that. So whenever I am concatenating this with the location, these IDs are coming, these IDs are coming, but then, and these locations are coming, but then this location was not there on the other table, so blank. These names were not there on this table, hence blank. So this is how this will look like. So this is axis equal to 0, which is the by default one. So whenever it's axis equal to 1, it will basically add things horizontally. See here, the problem is ID is getting repeated. That is the problem. Whenever we were doing joins, join was intelligent enough to not use the ID twice. So it was placing ID only once. The ID was not getting duplicated, but that is the problem with concatenation. It will not even look at the inside content. It will just see the column names and just put them apart. So that is for axis 1. At least for axis 0, it will look for the common names and append them together. But that is not the case with axis 1. It will simply take one data set and just put them together. If the number of rows matches, fine. What if one has 3, one has 4? Let's say there was another entry. So all the prior values will be blank and then the next one would have some values. So that is how a concatenation will happen. Right. So here we try to do something, I guess. Just some merging example that we saw here. Okay, quickly I'll cover. So this is, let's imagine, so these are two data frames. This is left data frame, this is right data frame. Now, whenever intentionally I want to create some missing value, I have to use np.nan. np is numpy. Numpy.nan is something that I have to write intentionally. Otherwise, it will, if I keep a blank, it will consider that as an element, not a blank. But this will get treated as a missing value. Python will understand this is a missing value. So it is created. This is a left table which has transaction ID, user and their values. And the right table is the user and their favorite color. So if I want to see, let's say, all the transaction. Now, what is the common element? Common element is user ID. So we can use user ID to connect these two tables, to join these two tables. So let's say my objective is to get the transaction value and the transaction ID whenever the favorite color is missing or blank. So for that, what I have to do? First, I have to join them together. Right. What type of join? I have to go for an outer join because I don't want the common elements or something like that. I want everything. So that is how I will do. So this is what I'm doing. I'm getting everything. And out of everything, okay, we tried it based on red. So we wanted to see for red, what has been the transaction amount or this transaction value. So if we look at manually, we can see there are two rows where color is equal to red. So what I need basically these two. So the join part is done. Now these are things that we have already seen. Just filter out whenever the value is red. And then just we have added that. So this particular statement is where we have added sum of these two rows and eventually collected that into a new variable. And just, this is a series. S1 will be a series. And series' third element is what I want to access. So this is 0, 1, 2. So outcome of 2 is 1.37, something like that. So that could be a real world practical example of joins, in a real world. Like this is one transaction related table, which has all your customer transactions. And this is all the customer level informations. Now, first we have to bring them together. And then we have to, based on a certain condition, we have to fetch all the, transaction amounts and those kind of things. So this is one of the example that we tried to see yesterday. So, Sian, were you able to follow Ranjit?
Yeah.
Yes, yes.
And Ranjit, it has been twice for you. So,
Yeah.
is it helpful?
Yeah, it's helpful.
Okay. Okay, so that's on the join part and concatenation thing. Essentially, these are the two things that are very much needed in an industry, in a real world practical case. Join data sets together, data frames, and then you should know how to filter out things. How to filter out things to get to those relevant things. So these are the basic things that you do every time. Now, I just wanted to do little bit on this thing. And today, what I'll do, I'll share some questions like I did last time, that but you guys were not able to complete them. So do you think that would be doable? So if I do something on Friday, or that is something not needed? Ranjit Sian?
Yeah, you can
Mm,
give us homework.
fine.
Yeah, so it will be like I will just give you this data frames, like these kind of things. These kind of things I will give you how to create a data frame. You need to create data frames, and then I will be asking, let's say, a couple of scenario based questions, like I need to know which is the minimum value of a particular ID and those kind of things, where you have to do some joins on your own, some filters on your own, maximum minimum on your own. So those kind of questions. So it will be interesting and it will be good for practice as well. So that is one thing. And so today I was thinking of starting analytics. To start on data analytics and statistics. Now, what do you know about data analytics?
It analyzes the data and gives us the result.
Yes, that is right. Anything else? Sian, you want to add?
Studying like patterns in the data,
Huh? Just be a little loud, sir.
uh, like looking for patterns in the data. Yes.
Yes, that is also true. So one is analyzing the data and to be able to provide your research or outcome. And number two would be to to see if there is any hidden pattern, if there are any hidden way of any abnormality present in the data or not. So those are few of the things that we can get out of data analytics. Now initially it was all about analytics, like you just name it. So I'm talking about early 70s or 80s, around that time. So because it was analytics more of, because that time the data access was very limited. It was mostly using CSV and Excel, this kind of data. But now with the advent of more types of data, like text data, image data, video data, audio data, these all are now gets treated as type of data that a computer can process. That is when the name started changing from data analytics to data science. Now people are saying it's not only analysis that we are doing, it's also we are manipulating data. We are, adding new data, we are generating new data. We are, doing lot of things with respect to data. So that is when this data science came into the picture, and that is when the name started. Data science and data scientist and all of that. Now, so the basic was the data analysis or data analytics. So so that we already know, right? So if you have a data, like if this is your if this is your data that you have been asked to do some research on it. Somebody has given you superstores sales data. So that is a data. What you have to do is you have to understand what this data is doing, what this data is talking. So for that, there are multiple ways of doing it. There are multiple ways of, understanding the data. One could be using BI, which is business intelligence. What is business intelligence? Business intelligence talks about the visuals of data. Let me just write one more thing. Later we can talk about details. Import Seaborn as SNS. Seaborn as SNS. Let me import this library quickly. So what SNS Seaborn is, this is an image library basically. Now just let me SNS dot. Hold on, why it's not coming? Yeah, SNS has been executed. SNS dot paste plot of data is equal to df, x is equal to cells. This is not looking very good. Unit price. Let's try. Okay, this is at least not really good, not really helpful to understand. If I do this, yeah, this is still better. Still better. Comma u is equal to let me put order priority. Let me just give you this. Why it's not working here? Data source must be. Why is it? Oh, sorry. It has to be within a data frame. There are too many of them, but this is still acceptable. This is still acceptable. So this is all about BI. Now it took some time. Sorry for that. But these are two libraries that we have used to create this particular chart. What is this? This is a box plot chart. So this type of graphs where it looks like a thread and then there is something on top of the thread. This is your box plot graph. So why are we using it? To understand the data. If we scroll through the data, we can calculate lot of mathematical calculations. But if we use BI, business intelligence, BI can help us understand this, we can, it will help us to understand how visually the data looks like. So that is one of the things that we can do with the help of BI. Now, what are we doing here? In AX, we have considered order quantity. Order quantity is a numerical field. Order quantity talks about how much of order has been sold. And order priorities talks about what is the priority of that order. Was it low? Was it high? Was it medium priority? Now, if we come here and have a look, we will see these are the different categories of order priority. Either it was low or high or not specified or medium or critical. And if we look at this, then for order quantity, the minimum order quantity was 0 and the maximum order quantity was 50. That is the range. Then within that particular range, these lines are the means. These lines are the mean. That means the average. So for critical, whenever the order priority is critical, that time the mean was somewhat around, let's say 25. But when we are talking about medium, that time the average has shifted. That means more number of units has been, orders has been sold for order whenever the order priority is medium compared to critical. And we can see the line is pretty much straight. And what this box is also telling me, this box is also telling me the minimum number of, like, if I had to put that in a range of most number of cells, then mostly the cells have been between, let's say 13, 14 till less than 40. From here till here, mostly, or between 10 and 40. So whatever sales have been happening for me in this data set, mostly the sales lies in 10 to 10 units to 40 units. One or two have been 0 and 50, that is the ultimate range, but mostly it lies between this particular range, right? So because all the values are between this particular range, so that is one thing that we are able to get from BI, business intelligence. right? So business intelligence is something which is already there in the data. We are not creating something new. Like, have we created anything new here? No. These sales and this order priority orders, these are already there as part of the data. We are just visualizing things so that it will be easy for us to understand. We can quickly take a call that, yeah, this particular order is happening, more number of sales or something like that. Or let's try it with something else. Let's try with this one, ship mode. Let's see how things are changing. No, with ship modes also, this has been more or less same. Just that for delivery truck, more number of sales have been happening. For express air, the sales is mostly limited to a certain range. So those are few of the types of analysis that we can do. And this will just help us to visualize the data, to understand what has already been happening. Now, that is one part. That is one part. Now, the another part is, what if we want to predict something out of it? What if we want to forecast? Like, we have the sales data on for day basis, right? For every day we have the sales data. What if we want to predict, like, on a certain day, what will be the discount, what will be the sales or sales, or shipping cost and unit price? What we want to predict, those kind of things. So that also needs to be answered, right? So that's when we need statistics. So if I have to divide, so let's say this is analytics or data analytics, we can say. Analytics can be divided into two parts. What are they? One is descriptive analytics, that is one thing, and another would be predictive analytics. So these broadly, so there is one more which is prescriptive, but let's not get confused with that for now. So that part is known as prescriptive analytics, but this is, so this prescriptive comes under this predictive only. So this is not something which is very different, but broadly, or for now, just ignore this prescriptive one. Just for now, just don't think about this one. And just pay your attention on these two, descriptive analytics and predictive analytics. So descriptive, as the name says, is about describing what are the things that has already happened, something which is past tense, like already happened. But for predictive analytics, that is something which, where you will tell about the future, right? So predictive is all about predicting new things. So if we take this data, for example, so where do you think this image will fit in? Is it descriptive or predictive?
Predict,
Hmm?
predictive.
Predictive, you're saying. Sian? And why do you think it's prescriptive?
Descriptive because we're showing like it's a visualization of the data that we already have.
Exactly, that is the point. So that is kind of a past tense. There's something which has already happened. I am not doing something new here. So I have this data, I'm just collating and visualizing data in a certain form that I can understand what is the hidden pattern or what are the hidden details, those kind of things. So I am fetching informations out of it. So that will go as part of descriptive analytics. But for situations where we will predict, like, what will be the sales tomorrow or what will be the profit after 6 months. So those are the type of things where we want to forecast something or predict something. Those will be part of predictive analytics, right? So those will be part of predictive analytics. Now, for descriptive analytics, mostly we will rely on BI tools and these kind of things. For we will rely a lot on, BI tools. BI means business intelligence, or let's say visualization tools. Visualization tools like what do we have? We have Tableau, Okay, we have Excel. Let's start with the basic. We have Excel, we have Tableau, we have Power BI. So these are the three major ones, and then we have a lot of other visualization tools which will help you to visualize the data. So that is one mode of doing it. Then we have what? We have analytical tool. This is visualization, analytical tool. Like again, we have Excel, then we have SAS, we have Python. So what these will do, these things will essentially do the analysis of things which have already happened, like, taking the mean or calculating how much has been the range of sales, right? So the sales lies from, or let's say the discount. So I want to come up with something where I just want to, offer more discount to people who have purchased more based on this data. Can we do it? Yes, certainly. We have customer details like customer name and customer segments, from which segment that customer belongs. We have that. So if we divide our data based on this customer segment, and then if we see which particular segment has contributed more sales and more unit purchase, and their shipping price was high. So if we can calculate those things, and then let's say if we sort them on certain things, how can we do it? We have already seen GroupBy. So we can leverage GroupBy to do this summarization. So once we do that, after then we can take a call that, okay, out of all the customer segments, okay, let's quickly see what are all the customer segments we have. Dot, how do we see? We will use value counts for categoricals. So these are the different customer segments we have: corporate, home office, consumer, small business. So out of this, if we use a group by to calculate the number of sales and number of unit price sold and all of that, then we should be able, do you want to me to do it now, or I just go with the theoretical things?
We can copy the theoretical another, I think 30 minutes. Anything is fine.
Okay, then because I don't, because this is not the main thing, this is just to make you understand. Like if I have to do a group by df dot, do you remember the group by things? Group by, then by is equal to your customer segment, and then after that, whatever column you specify, sales dot sum, that is how it's going to give you sales mean or whatever. So these are the average means and all of that. So what I want is, rather I want for every customer segments, I want to see which customer has been more, which segment has been more beneficial to my business. I want to offer them more discounts. So I need, let's say, units sold, or what is that? Order quantity. This is a numerical field. Order quantity I need to know. This is order quantity. So average, or let's say sum. So we can see this segment, the corporate has been ordering a lot. That is one thing. And if I want to see multiple columns and multiple calculations together, do you remember what we used? No, we used something called aggregate. So Ranjit Sian, these are things which if you don't practice, you will forget. So if you keep on practicing, it will be there in your mind. Otherwise, you will just lose a track of it. So, okay. Dot aggregate. Within that, I have to pass them as a dictionary. So aggregate of, let's say, order quantity, sum of order quantity I need. So I would just put order quantity and then colon sum. That is one thing I need. What else? So this is one key value pair of a dictionary. I will need more sales. I need sales information. Sum of how much has been the sales. Sales colon sum. So if I just put these two, I don't know why the sales is coming in this. So if okay, let's try profit. Sales, or let's say average sales and total profit sum. Right now this is better. So what we have seen, order quantity, total orders, order of products from a particular segment, average sales from a particular segment, and total profit that we have earned from a particular segment. So if we contribute all of this, which one looks better? This dot, I should have used mistake based on order quantity, ascending is equal to, so ascending is equal to false will give the maximum at the top. That means in descending order basically. So based on order quantity, we have sorted. Corporate seems to have sold the highest number. What about profit? Is it, or let's sort by profit, because that is what is more important to me. Yeah, it's essentially the same thing. So corporate has been the best area for me in terms of profit, sales, and number of orders sold and all of that. So what I am planning to do, so what is the existing discount that we are offering? Let's see that as well. Average discount. If we have to add one more here, discount colon mean. So 0.04, that means 4%, or so probably same or little less we are offering. But considering the amount of sales and their contribution compared to other segments, what we can do is we can play around with this column. Like we can increase discount to these segments, and we can probably decrease the discounts on the other segments where the sales have been less. Now we have done a lot of things. We have done group buy and all of that. But going back to the basics, what is the first thing that we did here? We did descriptive analytics, because we know this is something that has already happened, and we tried to visually look into how it looks. Then we relied on data. So that visual part is done, and then we use the analytical tool like Python for our case to come up with these findings, and we can take a call like this corporate segment is the best customer segment. However, the consumer segment is not the best one. So you can play around. So you can just change the discounts accordingly to benefit your business. Now, something which talks about the betterment and risk improvement, that is all about your data analytics, where not only you're analyzing data, but you are recommending something for the improving the business, for reducing the risk and increasing the business values and propositions. Whenever we are talking about those things, that is completely what a data analysis is all about, or a data analyst does, right? So that is all about the descriptive analytics, where firstly we have to visualize the data, or we can do it in two ways. Either we visualize the data and tell the stakeholders or the customers or clients that this is all the data talks about, or we can use some existing analytical tools and calculations to come up with our findings. And we can say, now imagine if you look at the data, would you be able to say which customer category was good? No, not possible. But after this analysis, you can tell your client like, hey, I have this result. This is evidence that this particular corporate segment is performing better. I have taken three variables, and utilizing these three variables, I can take a call that this segment is better. So please work accordingly. This is the recommendations or something like that. So that is all about the analysis that you're doing. Now the predictive analytics, that's the important part. What is that? So predictive, as the name says, is something that you are predicting about the future. You are predicting something about the future. So for that, the first important thing would be statistics and mathematics. Now, don't get confused by mathematics is something else, or will not be going into very details, but understand these are two of the things that you need to predict something. And then, of course, you need analytical, like these two will be there. These two will be there, so there is a visualization tool to do the visualization. There is some analytical tool to do the analysis, but here the major difference or change will be your addition of statistics and mathematics, because without these two or without statistics, you wouldn't be able to do something called predictive. So you have to know that. Now, statistics is a huge thing. It's a people take 10 years to learn statistics. We will not be covering a lot of things, but at least the basics which will be part of data analysis, those are things that we should know, right? So that is what is predictive analytics is all about. So are we clear on that part?
Yeah.
Okay. Now the important thing is example. Okay, let me give you an example. So if I tell you, let's say if I have to, if let's say I tell you, Ranjit and Sian, that I need to know the average height of all Indian males or females. Let's say this is a question. So how do you think we can solve it? Just whatever comes up to your mind, just share with me.
Average height of the male will be like 5.9.
Yeah, on what basis you are telling 5.9?
You're
What is
asking
the
about meters and centimeter.
anything. The unit does not matter. Feet, inch, centimeter, meter, that's the different. But if I ask you that, Ranjit, I need to know the average height of all Indian males.
Okay.
What will be your approach?
On an average, generally the all Indians will be in 5.5 or 5.96 feet.
On what basis you are giving me that number?
Just on an observation basis. I don't have exact data.
Exactly. So that is a very important word you said, observation. That is a very important word. Observation. Now, what is that? Observation are or something, let me put it in a better way, sample. So in statistics, whenever we are talking about the entire thing, like here the question is for entire all of Indian males. So India has 140 billion 140 crore people, right? Out of them, I am assuming 60% or 70% are males. Let's say 50% are males. So that is 70 crore. So humanly, it is not possible to go and ask all 70 crore about their height, right? Practically not possible. What we have to do, we have to take some samples out of it. We have to take some samples out of the larger population. So just remember these words. These are important words. So population is entire data set. Sample is small subset of the population. Just remember these two things, right? So population is, and for our case, for our example, this is India. How much? Let's say 140 crore. But sample is, I have asked Indian male. Now, Indian male would be 70 crore, but humanly not possible to go and ask all 70 crore. What we can do, we can probably ask 70,000 or at max 7 lakh people. But that is also huge, right? So we will do what, 1 or 2%, or for the betterment, let's say 10%. So 10% of 70 crore is how much? That is also a huge number, but let's say I'm taking only 1%, that 7 lakh or something. Or let's make it easier, 70,000. So for the sake of understanding, let's keep it small. So what we will do, we will take a small subset of the population. We are calling them samples or sample, whatever. So out of that sample, we will go and ask all 70,000 male about their height. We will collect this data, we will average it out, and then we will extrapolate. So that is an important word. Extrapolate means you are extrapolate is you are just increasing the so you are increasing that small sample to the entire population, and you are assuming if for 70,000 the average height is 5.5, then probably for entire population it will be around that only. So that is a small call that you will take. So miking going up. Yeah. So that is something I will do. Once we have this data, then I will extrapolate it on the overall population, and I will say the overall population would be somewhere around 5.6 plus minus some errors. Some errors of how much? Let's say errors of 0.16, 0.16 foot. So that will be my percentage of error. And I have to say it with some confidence, right? I have to make this statement. I'm making this statement. So I have to make this with some confidence. So that is known as confidence level. Confidence level of how much? Usually 3. Either you say 90% or 95% or 99%. These are the different level of confidence based on which you will take a call. You guys following me?
Yeah.
So I've said a lot of things, but just consume one at a time. Just consume one at a time. So what was the objective? Objective was average height of all Indian males. That was the question. So my total population is 140 crore. Now for us, it's not possible to go and ask all 140 crore about their height. Okay, so for Indian male, the total population would be 70 crore. Sorry, not 140. That includes females and trans people as well. So let's say that some 70 crore. That is the entire population. Now we will use statistics because statistics is all about taking a small sample from the real data and predicting about what might happen if that same calculation has been processed for the entire thing. So out of that 70 crore, we have to do a sample first. Now, what is sample? Sample is small subset of the population. Now, there is something called strata. Okay, type of samples. Type of samples. That is very much important. What type of sample you want to do? Because based on this, your results will matter. Based on these samples, your results will matter. So so for this particular case, would you go to a particular state and take all 70,000 records? No, that is not how you will do, right? You will work it based on stratified. So there is a method called stratified. What is stratified? Stratified means you have to create multiple segments out of it. Multiple segment means, few states from North India, few from South India, few from East, few from West, few from the coastal areas, few which lives in the probably in the forest areas, few who lives in the outskirts, few who lives in suburbs, few people who are on the village area. So those are the different types of segmentation you have to create. And then you have to take individual data from those, because if then that will be stratified, because
Yeah.
strata is Stratified comes from strata. Strata means classes. So you have to okay, so Ranjit Sian, tell me, so for this 70,000 population, if I just go and ask from somebody from, from Tamil Nadu, will it give me an accurate representation of entire India?
No, it will not.
It will not, because why?
We have to go each and every state, and we have to take at least minimum of 5 to 7 people average. Then we
Exactly.
can come to a conclusion. This is an approximate.
Exactly. Now that term which you are calling, that term is known as stratified or strata. So you said like we have to take from every state.
Yeah.
So so you are creating multiple classes. So those are known as strata or stratified. So you have used multiple stratified classes. So one stratified classes is let's say people who live only people from all the states, from Kashmir to UP to
Yeah.
all the states.
Okay.
So that is one thing. Then all those individual stratas have to be randomly selected. Like you cannot go to a family and you ask all the people about their weights, because let's say there could be some families in Punjab who are usually taller, more than 6 feet.
Correct.
And there could be usually some people from Bihar who are probably 4 feet. So
Yes.
if you go and ask all those people, then your result will not be right. That will
Yeah.
not be accurate. Instead, you have to choose your strata in a random way. Random means randomly you will ask one person from Punjab, randomly you will ask one person from Bihar, from all the states. So randomly selecting stratified, this will give you more or less an accurate prediction, an accurate estimation of the of all the people across India, of all type of males across India. So type of sample is most important thing. What is the type, what are the different means, how are you selecting the samples out of it? Out of 70 crore, if we are choosing 70,000 for our analysis, now those 70,000 numbers have to be randomly selected with stratified classing. With stratified classing, you have to randomly selected the 70,000. Then you can say this might represent a larger segment of people. Like if we take one people from Punjab, you might get an idea about, okay, the whole family or that whole class might be around that particular height. And same goes for some other state or something like that. Now that is on the selection process. That is on the selection process, type of samples or data selection part you have done. Now, once your 70,000 data is there, next comes statistics. Next, I mean, this is all about statistics anyway, but next comes your this thing, your a particular technique that you have to use. So that technique will do the calculation, which is known as a test. A particular statistical test that you have to do. Now, what there are various types of tests we have. There is something called Z test. There is something called T test and other types of tests. So that is the second thing that we have to do. So once we have collected data, type of data collection is done. Let's say type of data collection is done. The second would be your statistical test. Once the test is, so this is where the actual calculation will take place. So guys, is it okay if I go 5 more minutes? Like
Yeah,
more
no
than
problem.
10?
No problem.
Okay. So let's say this, the second will be your Z test or T test or a type of statistical test where you will actually do the calculation, where you will actually, count the height of all 70,000, divide them by 70,000, all those mathematical calculations will take place. So this part where all the math will take place, calculations, math calculations and all of that. Okay, I'm done. Let's say I'm done with that. What next? After that, we have to take a stand. Okay, prior to that, I missed one. prior to jumping into the calculation, there is a hypothesis design part, hypothesis development or designing. What is this part? So this is where your actual hypothesis lies. So this hypothesis is, so what is hypothesis? Hypothesis is something which has already been defined. Like the sun, what we know, the sun rises in the east and sets in the west. We know that.
Yeah.
The earth moves around the sun. Moon is our satellite. So these are things that we know. Like whenever there is cloud, there might be rain. So
Yeah.
these are hypotheses. Like these are things which have pre-established with proper evidence and with all of that. Like, one of the hypotheses could be whenever there is rain in a cricket match, after that scoring run would be difficult. So that is also an hypothesis. And we call them null hypotheses. So what are these type of hypotheses called? These are null hypotheses. Why null? Null means these are already accepted hypotheses. Right? Like, this thing, if there is, whenever there is rain, scoring in a cricket match after rain is difficult. Or let's say it's easy. I'm just quoting an example. Right? So, that is a null hypothesis. That is something that has already been established. Now, let's say you are a researcher, you are a scientist. You don't believe that statement. You are contradicting that statement. You are saying, no, every time there is rain, scoring run is easy. So that, the ball can go in here and there direction, it will sleep, that, this, that. You come up with your counter logic. So that thing is known as alternate hypothesis, alternative hypothesis. So that alternate hypothesis is hypothesis. That alternate hypothesis is something that you will come up with your own. And for that, you will do the test and all of that. So anyway, coming back, so this part is the hypothesis development part. So for our case, this is where we will develop the hypothesis that what are we doing? What is the problem that we are trying to solve? Here, the problem is we want to calculate the average height of all Indian males. So that is the hypothesis that we are trying to build. And for that, we have to take certain measurement step, right? So what are those measurement steps? So hypothesis development, within that we have to see how much percentage of accuracy we will allow this model, because if you're talking about statistics, it's all about estimates. It's not real. 100% is, so let's say if I tell you that tomorrow 100% there is going to be rain, I cannot be 100% sure because I don't know what will happen tomorrow. There
Yeah.
might not be rain. So always this is a value which lies between 0 to 1. It cannot be 1 exactly. It cannot be more than 1. It cannot be less than 0 either. So it will always be 99.99%. And what is that extra percentage then? So that extra percentage is your error. So it goes in such a way that 1 is your confidence and plus errors. So it could be like you are 95% sure that this will be the height of the person, but also you have to specify that you are 5% not sure. So 95% will be your confidence level. You will be confident 95%, and 5% will be your error, that okay, I'm 5%, I could be wrong, but 95% times I will be accurate. So that is all about the confidence level and all. Now these are the KPIs, or let's say these are the metrics. These are the type of metrics that you have to predefine before starting this particular test. So this will go here as part of the hypothesis development. As part of the hypothesis development, this is something that you have to predefine. and pre-store it. So these are the things that before jumping into the mathematical calculation, you will do all of this part. And after that, you will directly jump into the statistical test. So this test is actually taking all 70,000 plus, all their heights divided by 70,000 and all of the calculations, whatever it happening inside the z-test process. So you follow all of that. After that, the next would be performance. Performance. So what is performance? Performance is, we call it, let's say, model performance. Performance is where we will see whether these metrics are getting violated or not, or let's say validation. If I am validating, if I am, how much am I deviating from this? If I am following all those matrices, if I am, my confidence level is within 95%. If my error is less than equal to 5%, my error is, if it is the error is 8%, then I cannot take that model. I have to redevelop the model. So the error should be less, because that is the predefined condition that I have considered before starting this process. So once all that model validation is done and accuracy, all of that, once you're sure on this part, then you will move to extrapolate the same to the population, to the entire population. So once you're okay that your samples are good, the sampling process is good, the hypothesis is accurate, all the statistical tests are as per process, model has been validated and it's giving good results. So then you will extrapolate this to the entire population, and then you will come up with this will be your final, let's say, finding. This will be your final finding, that with 95% confidence, I am sure that my average height of all male in India will be 5.6 feet, plus minus some errors of 0.16. That means the value will range between this particular range, like 5, or let's say this is, let's put it 1. So 5.6 minus 1.16 is 4.43. That is 1. And 5 point this plus 1.6, so 6.76. So what you can conclude is, so your values will range between this to this. Now this is statistics, so we cannot be sure and tell that okay, 6 feet is the exact height. No, we cannot do that. We have to take in the consideration of errors. And after taking errors, we can say with 95% confidence that for all Indian, average height will lie between 4.43 to 6.67. This will be your final outcome. So this is something which statistics will help you to do. And this is a type of descriptive analytics. Sorry, this is a type of predictive analytics. I'm also going wrong. So this is because you are predicting something for the entire population. You are predicting this for the entire Indian population. You don't know that. You have taken only a small subset, and based on the subset, you are predicting for the entire population. So that is where statistics will come into the picture. That is where these different tests, sample, population, confidence level, z-test, t-test, all those things will come. Then your model validation, and finally extrapolating to the entire population. This will be it. Anything, any questions or anything?
No, nothing. Today
So-
class was interesting.
Sorry?
Today class is interesting.
Okay. So, yeah, so that is what these things are all about. So you at least got a brief about the things, right? Data analytics, descriptive analytics, predictive analytics, how statistics is coming into the picture, where statistics is coming into the picture, how it is helpful. So going forward, next week, we will spend more time on this, understanding in details how these things are working. we
Okay.
can take one sample example and we can do something on that.
Sure.
And then we will try to do the same on Python, because eventually all of this, so earlier people used to do on pen and paper. Imagine early 60s or during that time, all the statistician or scientists used to do all of these calculations on pen and paper. But now with Python, R, all these languages, it's just couple of lines of code and all of your result will be there. You don't need to do any calculation on your own. Just you should know where exactly which module to use, what function to use, that's it.
Okay.
Yes,
Sian,
sir.
any questions?
Uh, I think, yeah, it's okay for now. Yeah, when you explain more detail later, yeah.
Okay. So for any doubts, just let me know and we can just pause and try to explain that with a real world practical example. So it will be better to relate and will be easy to understand. But yeah, let's stop today now. And next day, so meanwhile, I will just do one thing. I will just give you some, this data. I will just give you these things. Yeah, some sample data frames. So all you need to do on your end is run them, create the data frames, and then I will ask you some questions. Right? The questions will be like, let's say, which user has the highest transaction value from the left data frame? So it's this one, this user ID, Anna. Then I might ask you for all the, from the entire data set, which user is the highest or which color or those kind of things. So in that case, you have to just join them with all of that, and then you can need to use some filtering, selection, maximum, minimum, those kind of things. So it will be easy. For any difficult things, you can just, I will be uploading this into that GitHub location. Just go ahead, download it, and it will be easy for you. In case if you don't want to download it, right? It will be, you can at least have a look how this thing goes. So if you go to any part, just click on that particular file, and here itself it will show you the codes. You don't need to open it in your end as well.
In GitHub. Huh?
Yeah, just take this link, just this particular link. Thank you so
Okay.
much.
Thank
Yeah,
you. Thank you so
take
much.
care.